Good morning. Welcome to the first session of thermodynamics. I am M. Pradeep Kumar and I am going to deal thermodynamics for second BTech first semester in mechanical engineering at Lindy Institute of Engineering and Technology. In this video, we will discuss about the introduction and applications of thermodynamics. What is meant by thermodynamics? Thermodynamics is a subject which deals with the interrelation between heat and work. The name itself indicates thermo and dynamics. Thermo means heat and dynamics means motion. Here motion in the sense work transfer. So the subject will clearly deal with the interrelation between the transfer of heat into work and work into heat. That's why this subject is defined as the science of energy transfer and its effect on physical properties of the substances. Going into its applications, the subject has got various applications in general view. Like the laws of thermodynamics are used to run internal combustion engines and power plants and gas turbines and air conditioners and refrigerators and jet propulsion and mainly in chemical and food industry. While coming to the application of this subject in thermodynamics in your curriculum, that means in mechanical engineering in your curriculum, there are many subjects which are related to thermodynamics. That's why subject is base subject for them. Like first one, the fluid mechanics and hydraulic machines, and then applied thermodynamics, where you will see about IC engines and power plants, and then IC engine and turbo machinery, and then automobile engineering, and then heat transfer, and refrigeration and air conditioning, renewable energy sources, alternative fuels and emission control in automotive, and cryogenic engineering, power transmission in hybrid and electric vehicles, gas dynamics and jet propulsion, wind energy systems, computational fluid dynamics, power plant engineering, and energy consumption and management. In all these subjects, to study about something, you must know the basic laws of thermodynamics, and those laws you will learn in this subject. So the course objectives for this subject are: first, familiarize the concepts of heat, work, energy, and governing rules for conversion of one form to other. Then relate different properties of matter using laws of thermodynamics and analyze the properties of steam undergoing various thermodynamic processes using tables and charts. And introduce the fundamental concepts and applications of thermodynamic cycles and impart the knowledge on mixture of perfect gases and their properties using different laws and characters. These are the course objectives. So by the end of this course, the student must attain all these objectives. So while going into the syllabus, in Unit 1, we'll discuss about all basic concepts like macroscopic and microscopic viewpoints and different definitions and what is meant by quasi-static process and what is zeroth law of thermodynamics. And then we'll go for first law of thermodynamics and its corollaries. Then PMM 1, that is perpetual motion machine 1, and limitations of first law of thermodynamics. All these things we will discuss in Unit 1. Going into Unit 2, second law, we will discuss about second law of thermodynamics and its applications and what is reversibility and what are the causes of reversibility. Here we will learn about Carnot theorem, and here we will introduce a new concept, entropy and Clausius inequality, and we will discuss about availability and irreversibility of energy for flow and non-flow processes. And in Unit 3, we'll completely discuss about properties of steam and how to use steam tables while evaluating the properties of steam. Going into Unit 4, there are many relations in thermodynamics that has to be discussed, and all the things will be discussed in Unit 4. And also we'll discuss about different cycles like Otto cycle, diesel cycle, and dual cycle, and their PV and TS diagrams in the air standard cycles, which will be useful in further subjects like applied thermodynamics. Coming into the fifth unit, here till now we will discuss about everything about steam, and from now in fifth unit we will discuss about other gases which are taken as perfect gases. So here in this unit we will discuss about mixture of perfect gases and different laws that are related to these mixtures. That's it about the syllabus of this subject. And we are expecting these course outcomes from the student by the end of this subject. That is, he can identify concepts of heat, work, energy, and governing rules for conversion of one form to other. And he is able to explain relationships between property of matter and basic laws of thermodynamics. And he can be able to explain the concept of available energy for maximum work conversion. He must be in a position to analyze the steam properties to understand working of steam power plants, and he is enabled to provide fundamental concepts of thermodynamic cycles using in steam power plants, IC engines, and gas turbines. Thank you for the opportunity and thank you. This is the ending of this section. Thank you.